Have you ever wondered how the sun produces so much energy? What if we could bring that same power right here on Earth? Welcome to the incredible world of nuclear fusion, the energy of the stars, now being recreated by scientists to power our future. How nuclear fusion reactors work. The power of the stars on Earth. Nuclear fusion is the process where two light atomic nuclei combine to form a heavier nucleus. In doing so, a tiny amount of mass is converted into a huge amount of energy, according to Einstein's famous equation, E equals mc squared. Fusion is the opposite of nuclear fission, the process used in today's nuclear power plants. Instead of splitting atoms, fusion joins them together, and it's far cleaner and safer. This is how the sun has burned for billions of years, by fusing hydrogen into helium in its extremely hot and dense core. Unlike fossil fuels, fusion doesn't emit carbon dioxide or cause air pollution, and unlike fission, it doesn't produce long-lived radioactive waste. The fuel, mostly hydrogen isotopes like deuterium and tritium, which can be extracted from water and lithium. That means virtually unlimited energy without destroying the planet. One glass of seawater contains enough deuterium to power a fusion reactor for days. Sounds like science fiction? It's becoming science fact. So how do we make fusion happen on Earth? We need to recreate the sun's conditions, millions of degrees of heat, in a machine. One of the most promising designs is called a tokamak, a donut-shaped chamber that uses magnetic fields to contain superheated plasma. In a fusion reactor, hydrogen isotopes are injected into the chamber where powerful magnets squeeze and contain them. Then they're heated to over 100 million degrees Celsius, hotter than the sun. When they collide with enough energy, they fuse, releasing energy mostly in the form of fast-moving neutrons. There are several types of fusion reactors in development. One, tokamaks, like ITER in France, the world's largest fusion experiment. Two, stellarators, which twist magnetic fields into complex shapes for more stability. Three, laser-based fusion, like at the National Ignition Facility in the US, where powerful lasers compress fuel pellets to spark fusion. Each has its own strengths and challenges, but they all aim for the same goal: clean, limitless energy. Fusion is incredibly difficult to achieve. The main challenges are sustaining the extreme heat without melting the reactor, stabilizing the plasma, which is chaotic and hard to control, producing more energy than is put in, what scientists call ignition. Yet, despite the challenges, progress is being made. In 2022 and again in 2024, scientists achieved net energy gain for the first time in laser-based experiments. Projects like ITER, Spark, and private startups are pushing boundaries. Experts believe fusion power could be on the grid by the 2040s. Imagine a world powered by clean, safe fusion energy. No blackouts, no pollution, and no fuel wars. This is not just about technology. This is about the future of humanity. From the heart of stars to reactors on Earth, fusion represents one of the most ambitious quests in science. The journey is long, but the reward? A planet powered by the same force that lights up the universe. Thanks for watching. If you enjoyed this video, hit that like button, share with your friends, and subscribe for more deep dives into science.